Hello, Dr. Tosh Fiend. This is Josh once again, coming to you with digital twins and the railway system. I found this article on the railway system. I really love trains. I'm a huge advocate for train transportation and shipping for logistical purposes. I found this very interesting and personal for me, also because it is very scientific and mathematical. The math is very deep. I only have a minimal experience, so I will not claim to know all of it, but I do um, have the ability to interpret some. This was very cathartic for me to get to see into a digital twin and some of the science of it. Um, this paper was made for the purpose of detecting train derailments, as it says here. This is the augmented digital twin for railway systems. So the railway system itself is the locomotive and the coupler system. All of this is being managed in real time by the sensors and the systems, while this is determined by the augmented portion of the digital twin. So this is not real, but this is um, derived from this. And this is where the magic is happening for our purposes. It is a truly numerical program where they are using machine learning and white box algorithms, which I'll talk about in a second to do this. Here are all of the dimensions, coefficients, and parameters that go into this model. And these are their values, which I find really interesting. So we can see the weight of some of these factors and how they influence the train derailment model. For example, the entire mass of the wagon is weighted very high. That is a good indicator of derailment, while the side frame mass is weighted low but still positive, as well as the roll, pitch, and yaw. If your train is tipping, it's probably a bad situation. As well as these coefficients. I find them to be magic numbers in practice, but I am a fledgling software engineer. Um, but anyway, very interesting for me to get to look through each of these and figure out sort of where the magic's happening. They do have a generic simulation, nothing fancy like the videos we've seen in class, but it does detail the simulations that they will run on their twin when trying to detect the derailments. Um, Most of this looks like it's written in Python. I recognize these charts or the picture of the charts. I'm scrolling past these because I do not understand the science. Here, I've studied this chart for a good 15-20 minutes. All I know is that this derailment index is derailments are rare, but there are some derailments, and math is hard. But it is not impossible to derive. Most AI models are um, done with black box algorithms where they learn backwards and forwards. I'm sure you know the science, but this is all done with white box algorithms so that they can know exactly why there was a false positive and why there was a false negative. So they're able to get the highest accuracy possible by directly altering their models. They know what decision it made, when it made it, and why it made those decisions. And the R squared model score is an indicator of quality or accuracy. There's a lot of math behind it, but I consistently forget. Um, I will scroll past more of the extreme jargon, just get to the conclusion. But in conclusion, by using an existing digital twin and augmenting it, they've been able to achieve an R squared score of 99 which is excellent, nearly perfect. So with a white box algorithm, they are able to basically guarantee their trails will not derail. And if they are, they will know beforehand and they can prepare for these things. I think this is a great step for transportation and enforcing rails. And I'm very happy to dive into some math just briefly, see how it works. Um, I have a long way to go in school, but thank you for watching. Have a good one. Bye.